we have to keep questioning. We can't stand still, because the challenges are not going to end. And for all our hopes of establishing a colony on Mars, I think we all live on this tiny little rock called Earth, and the Earth itself is going through several challenges. So I think if we can use science to solve the fundamental challenges that we are faced with today, I think that's going to be create a big difference in the lives of everybody, right? The whole premise of this is we are going to consume all the resources that are there on this planet, and we need to in some way abandon this planet, move to the next planet, consume all the resources over there, and then we need to spread our wings and somehow harness all the energy that our sun is able to create. So I think there's this Kardashev scale as well, which has been laid out. But my question is, everything, be it the planet Earth or the sun or everything in the universe was created. So you just have to figure out what is the process of creation. Is the universe just made of hydrogen, or do we have access, to somehow fuse them without, creating big explosion? Because you have to understand that space not only exists between planets, but it also exists between atoms. It could also mean that you and me are somehow entangled. We alter, each other in some fundamental way. Why does gravity exist? What exactly is its nature? How exactly is electricity created? Just imagine someone from this era living 200 years from now, living in that world. Can you imagine how different that world is going to be if all these things were possible? Yeah. It's going to be, awe-inspiring, and very science fiction like. We have global warming, melting ice caps. We have more adverse climatic events that are taking place, which put a lot of burden on our infrastructure as well, with respect to displacement of people, power outages, damage to infrastructure. So I think solving the energy challenge is a more pressing concern. I think even the whole world, wants us to, adopt renewables or cleaner sources of energy in a fundamentally drastic way. Let's go back and look at what we have studied and the way we have studied engineering. So we have been told that a metal has certain properties, uh, and we have been told that these properties will vary. Let's say with temperature, it'll vary with pressure, it'll vary by certain parameters, right? We have been given a beautiful formula, and since I'm an engineer, I also know that there are a lot of correction factors also that we bring into the picture. Uh, but it doesn't go into the question of why. And I think the whole purpose of pursuing science is to get to the truth of the matter. And today we have several observations which bring into question everything that we have learned so far. And I think beyond this, if we can evolve science to go into the fundamental nature of the universe, can we break it into even smaller units and we can understand the universe in a fundamental different way? I mean, just imagine the kind of things we will be able to achieve out of that. So, for example, you take space travel. It's not possible for us to first lug all the fuel from the earth into space and then use it to travel anywhere. It's not possible to jump from asteroid to planets to accumulate the fuel. So we need to be able to get this fuel from space itself in some way. So propulsion is a thing that we have to solve in space. And maybe if we go and relook at the question why, and ask ourselves why does the universe work the way it does. I think it's possible to generate some beautiful ideas on propulsion, and even our day-to-day lives, I think, can be made better with science. I mean, we have seen the benefits of investing in science and technology. Today, sitting in one part of the world, we are able to speak to anybody in
Yeah, we
any
never
corner of the.
imagined that earlier, that we could, I
Exactly.
think even like almost
Yeah.
20 years ago when,
Yeah.
we started to have phones in our hand,
Yeah.
it was something that was very exciting. And now suddenly it's a completely different dimension that we are in.
Yeah. So I keep thinking, if someone from 200 years back were to come and live during our era, he would find everything magical, and he would really question as to how is it possible that such a drastic change can be brought about.
A lot of it has to be because of a lot of why that we have asked in science, right?
Yes.
So in your last podcast, which was very interesting, there were some very interesting challenges that you brought up towards how we think about science. But one question which came to my mind was, haven't we actually asked enough whys already? Haven't we done enough research on science already?
We have come a long way, right? But I think the fundamental structure that we have today is still close to 100 to 150 years old. Um, from your electricity to your quantum, I don't know how many people know, but the roots of modern quantum theory are over 100 years old. It was in the 1924, that the first fundamental of quantum theory was proposed by Heisenberg, and we'll be celebrating a century of that. And it's time to go beyond. I mean, we are standing on the shoulders of giants who challenged the way the universe works, and they came up with some beautiful
Yeah, right from
explanations.
Galileo, there has been some
Yeah.
very good and very daring challenges.
Yeah, and I think if we can go beyond all that during our era, I think it's a magical, thing, right? So we have to keep questioning. We can't stand still, because the challenges are not going to end. And for all our hopes of establishing a colony on Mars, I think we all live on this tiny little rock called Earth, and the Earth itself is going through several challenges. So I think if we can use science to solve the fundamental challenges that we are faced with today, I think that's going to be create a big difference in the lives of everybody, right? So I think it's good that we are at this stage, where we can question, and we can go, and we can definitely go beyond whatever has been done, and I think the future is going to be bright.
We know about space a lot from the last 50 to 100 years,
Yeah.
but majority of it in the last 50 years with all those Hubble telescope, now
Yeah.
JWST, and the
Yeah.
space travel.
Yeah.
But given the size of the universe,
Yeah.
what do you think? How much do we actually know about space?
Okay. So when you talk about the size of the universe, and the observable universe, uh, we face the challenge of geometry as well. So you just imagine, a big circle which is the universe, right? And we are a tiny dot over there, and we see, around a circle from the point of observation that we are. Uh, can you really gauge the size of the universe based on how much you are able to see? Maybe the universe is much bigger than that, much vaster than that. I mean, much older than that. And I think JWST has brought about that change, because we thought the universe was 13 billion years old. But JWST has observed galaxies which are billions years old, 13 billion years back. So, what is the age of the universe? And if the age of the universe is under question, that means a lot of, premises regarding cosmic microwave background, Hubble tension, the rate at which the universe is expanding, where the singularity, comes. All these come
It's
into
given us
question.
more questions than answers sometimes.
Yeah, a lot of scientists are saying that all our models of cosmology are broken, and that is true because it has raised more questions, and it's up to us to answer.
Yeah. And do you think that our space research, we are learning new things which questions our understanding of space? Is it happening every day out there, or is it now that we are fixed on one theory, or what's happening on the space research?
There are several observations which challenge, and it's not just JWST, but I think in terms of our understanding of Jupiter's moons has also undergone a big shift. Several probes have been, now landing on the moon. I think Japanese have landed, Chinese have landed, and in terms of solar observation as well, we have launched several probes. One big question is on one of the moons of Jupiter, they discovered volcanoes, which challenges our understanding of how can, a moon of a planet which is so far away from the sun that not enough radiation reaches it, how does it have active volcanoes? I mean, what is the source of heat? When was it created? And these are questions, which we have to ask on planet Earth as well. Is it just because from the cooling, of a hot ball that we have a magma layer underneath, or does it get replenished with heat from the solar radiation, or is there some other mechanism whereby the volcanic activity increases and decreases? And in terms of motion of galaxies, we still haven't discovered anything close to what dark matter is made of. There's a big question mark around that. Can we mathematically build a model for space, give it properties, and does it explain everything that we see? Does it explain why planets rotate around the sun? Does it explain why every planet moves in the same direction around the sun? Does it explain why, be it a big object or a small object, when it is at a certain distance from the sun, why does everything move at the same velocity? And it all started with Galileo, Kepler, who propounded certain rules which have to be followed and obeyed. And when you look at the galactic scale, all these rules break down. That is why you have to invent something called dark matter to explain how these rotations take place.
But how does an individual life, or how does it change for us, people living on Earth? Does it bring any change on how space being a fluid? Okay, yes, space is a fluid. So what?
Yeah, I think the first difference that it brings about is you have to understand that space not only exists between planets, but it also exists between atoms, right? So now just imagine a gas. Uh, it has a different density, right? You heat a gas, it expands, it has a different density. But what is between the atoms?
Nothing.
So now, if you treat space as a fluid, then that means there seems to be a medium between these
There is
atoms as
something
well.
between these atoms too.
Correct.
Okay.
And then you look at what exactly is quantum entanglement. A quantum entanglement is when you change either the spin or some characteristic of an atom in one region of space, and even if there is nothing in between, it seems to directly affect the orientation or the behavior of other atom, which is at a significant difference. But if you know that the medium exists between these two, and in some way these atoms are altering, the state of the medium between them, then you can explain quantum entanglement. Now you imagine what all things would become possible if you are able to explain quantum entanglement. Would you be able to recreate quantum entanglement at room temperature? Because now you have to take it to close to absolute zero, to make it a usable phenomena. It could also mean that you and me are somehow entangled. We alter, each other in some fundamental way. But it also means that now you have a possibility of answering the why. Right? Why does gravity exist? What exactly is its nature? How exactly is electricity created? Is it that one quantum field is displacing another quantum field? And this, gives rise to an observable phenomena called electricity, right? And then, if you know the direction in which it is naturally flowing, you can, figure out ways to, use it for our benefit. And I'm confident that this thing, is going to be the next thing. We can call it quantum electricity, where you use
Great.
quantum phenomena, quantum fields, and your understanding at a very fundamental level to create the energy that we need. I mean, it's going to be clean. It's going to be sustainable. So Richard Feynman also observed that if you go to the upper atmosphere, the state is already at 400 volts, and at sea level it is at 100 volt, right? So every electrical measurement that we take is with respect to this 100 positive volt, right? So when we say 100 volts, it is 100 plus 100, 200 volts, right? So electricity is already there in the atmosphere. You see lightning, right?
Yeah.
So what generates this lightning? That is electricity. That's a form of electricity, and it's at thousands.
That's the
And it's
electricity
at
that we see
and it's
actually.
at thousands of volts.
Yeah.
And if one quantum field displacing another quantum field is already generating electricity for you, it is just about figuring out other useful ways in which you can utilize this. Maybe we can increase the efficiency of things. Maybe we can build exotic materials out of it with magical properties. So to
There are
speak.
endless possibilities that will open up if we actually start thinking about how we can, use this science into something that can get, that can be converted into energy and
Yeah,
converted into matter.
and as we are talking, you gave me an idea. I mean, today we are communicating by sending light. Could we use entanglement itself to change the way we communicate? So to what extent can we use entanglement? Right. So is faster than the speed of light communication possible? So it's a very interesting world of
Is faster than
possibilities.
speed of light travel possible? That's the
Yeah.
interesting question that I have.
I think most of the thing is going to be market driven, right? So let's say you have a new technology. So now you will have to look at where can you apply it, right? And where can you apply it where it has most impact. So I think energy is a field, which can do with a lot more, advanced science into it, because burning fossil fuels, adds to the pollution in the atmosphere as well. So, I think it'll fundamentally alter the way we generate energy. So, I think that is definitely going to be the focus. But it doesn't stop over there, right? When you alter your understanding at such a fundamental to such a fundamental extent, it will impact every other field of science that we know. It will impact us in with respect to medicine, with respect to electrochemistry. Maybe you can change the energy states required to split water into hydrogen and oxygen. And could we use this hydrogen for some useful purposes? So the key is to move in one direction. and of course everything will open up after that. So, and if we can solve the energy crisis, I think that is the best news that the world would have received in several decades. We have global warming, melting ice caps. We have more adverse climatic events that are taking place, which put a lot of burden on our infrastructure as well, with respect to displacement of people, power outages, damage to infrastructure. So I think solving the energy challenge is a more pressing concern. I think even the whole world, wants us to, adopt renewables or cleaner sources of energy in a fundamentally drastic way. So, and it is possible. And it's just a question of, putting together a team, getting the right kind of investment. And
Time a research comes out that we just can't imagine how it will cascade, how it will change
yeah,
our future. And this is very interesting that when we are looking at something at a universal scale,
yeah,
and then we are looking at atom level, there's something that connects the idea of so large and so small,
yeah,
and it has answers to something which will fundamentally again change how
yeah.
the world works, and how we utilize things every day. So on this research, do you think there's something which is currently happening already, or what all actions can be taken now? How we can start thinking? Is it that we need to challenge more people out there? We need to tickle more brains out there that think what's why this is there.
Yeah, so currently, a lot of effort is going into superconductors, right, and into quantum,
It's market driven, as you said. Yeah.
and quantum computing, and of course the whole, focus on superconductors is, of course, energy. And also, into medicine. And then, the next focus is, of course, your fusion, making fusion reactors work. Should we use hydrogen? What about space travel? Could we establish a base on the moon? Could we mine asteroids?
But these are more like what questions, what needs to be
Yeah.
done, what needs to be done. These are not like why questions, why we have to think differently to reach there. So,
Yeah, so I think the whole premise of this is we are going to consume all the resources that are there on this planet, and we need to, in some way abandon this planet, move to the next planet, consume all the resources over there, and then, we need to spread our wings and somehow, harness all the energy that our sun is able to create. So I think there's this Kardashev scale as well, which has been laid out. But my question is, everything, be it the planet Earth or the sun or, everything in the universe was, created. So you just have to figure out what is the process of creation, and maybe you don't, need to keep hankering over resources and think that you need to mine asteroids, you need to, go to a different planet and, strip it clean. Maybe there is a different way of, creating materials as well. I mean, where does all the gold on this planet come from? Gold is so high up in terms of atomic number. It's a very heavy atom. So, if is the universe just made of hydrogen, or do we have access, to somehow fuse them without, creating big explosion? So, there are a lot of possibilities that will open up, and it's a very exciting future. And as you said, just imagine someone from this era uh, living 200 years from now, living in that world. Can you imagine how different that world is going to be if all these things were possible? It's going to be, awe-inspiring. and very science fiction like.
Yeah.
But it's possible, right?
Some of the movies will come true.
And the moment you think that, yeah, yes, it's possible. If you look at it this way, look at it this way, look at it this way, it seems to answer a lot of questions. And maybe this is the next frontier, and you can go beyond, and you can build you don't need to create new math, because I think we have done enough math, right?
Yeah.
But maybe we need to juxtapose math from different fields.
Maybe.
No, I think math has been very important, right? Because with math, you are able to quantify, you are able to predict. If you are giving a certain input, you know that I'm going to get so much output, and for you to be able to build any kind of application, I think that level of math is required. And we have developed several bodies of math, right? You have your complex number analysis, you have your divergence convergence models, you have your fluid dynamics, you have your probability distribution models as exist in quantum. You have the mechanistic models which we use, to build machines and things like that. And then, of course, you have the whole bit system, with respect to computers on how to compute, calculate. So I think it's just a question of taking the best bits from different fields and utilizing it to, create a unique mathematical model for this scenario. Science has always been about understanding the fundamental forces, fundamental driving fields, and then making predictions which are fairly straightforward. Otherwise, you go into an experimental route where you have to discover everything by experiment. It's like using brute force to crack an encryption code. It becomes even more challenging the more observation you keep building up, and that will never lead you to the right answer. So math is, I don't think we need to invent new math. Math is there, and it's all beautiful. It's a wonderful way to describe systems. Um, and I'm looking forward to really going further on this and working this out. It's exciting.
Have to start challenging and questioning the science and maths. Um, do you agree?
I agree. In fact, I believe that because science has become so math heavy today. You need to learn so much math. And then they say that now you will understand physics. I think that is wrong. Uh, anything you should be able to visualize first and use mathematics as a way to quantify things. And probably this is why a lot of the younger generation seems to have uh, moved slightly away from science. So it's time to rekindle, that joy of science, that joy of trying to find the truth, carrying out simple experiments, and saying, ki, I was able to do without having the need to, look at so much of the math. And getting them interested in the sciences, purely from a visualization perspective first. The math, is something that you will have to learn if you have to create applications from it. But that is something that you can take time to learn. But developing this interest will only come when you feel there is something new to be discovered. There's something magical to be discovered. So just giving them the whole confidence that you can definitely answer or raise several questions, and find very new interesting ways to answer these questions. I think that should be exciting. So I think a lot more, getting a lot more of the younger generation into the core sciences, and redefining the entire scientific perspective should be a very exciting journey.
So I think a lot of exciting things ahead about doing the further more research on how we look at energy, how we look at universe. So it was a great discussion. Any last thoughts that you have?
Uh, I think I have said somewhere that infinite energy is a possibility, not a dream. And I think this is how we should look at everything. That no challenge or no problem is insurmountable, be it in life or be it in science. And I think walking this path will definitely lead to great things for all of us.
Thanks, Amit.